Welcome to section 4.7. This is day 3. We're going to be looking at compositions of trigonometric functions. So the first couple examples here you can see, remember what a composition is we're looking for f of g of x. So you have a function inside of another function, and so you can see we have arc cosine of 5 pi over 6. And so one way that we can handle this is we can work inside and figure out what cosine of 5 pi over 6 is. So we'll evaluate this function right here. What is cosine of 5 pi over 6? So we're going to stick with arc cosine, and then cosine of 5 pi over 6, we're looking for the ratio for that angle measure. So 5 pi over 6 is here. We got a reference angle of pi over 6. So that would give us an ordered pair, and since we are in quadrant 2, it would be negative square root of 3 over 2 comma 1/2. So therefore cosine would be negative square root of 3 over 2. So we evaluated cosine of 5 pi over 6, replace that with negative square root of 3 over 2, and now we're looking at the arc cosine of negative square root of 3 over 2. So remember, now we're looking for the angle measure that gives us that ratio of negative square root of 3 over 2. So you got to think about your range for arc cosine, and that is from 0 to pi. And so since it's negative square root of 3 over 2, you're actually right back where you were when you did cosine of 5 pi over 6. So this is equal to 5 pi over 6. So arc cosine of 5 pi over 6 is equal to 5 pi over 6. Now, is it just coincidence that it's 5 pi over 6? Well, arc cosine and cosine are inverses of each other, so they can undo each other. They cancel each other out. But we do have to be careful because cosine, when we do arc cosine, it's between 0 and pi. So as long as your cosine of that angle is between 0 and pi, they'll always cancel each other out, and you don't necessarily have to show the work on this one. Now, if you look at example B, arc sine of 11 pi over 6 is 11 pi over 6 in our range for arc cosine. So when you're looking at arc, sorry, I said arc cosine, I meant arc sine. If you're looking at arc sine of a ratio here, what's your range values? Well, your range values for arc sine are from negative pi over 2 to pi over 2. So with 11 pi over 6, that doesn't fall within the range. But you can find the angle that does fall in that range that is equivalent to 11 pi over 6. And that would be negative pi over 6. So as long as you do that, you're able to kind of cancel these out. So once again, I'll show you both ways. For the second one here, we'll do the same thing we did for the first one originally, which is actually just find sine of 11 pi over 6. And so 11 pi over 6, so I'll rewrite this as arc sine. It's going to give us the ratio for 11 pi over 6. Remember, pi over 6 is ordered pair, is square root of 3 over 2 1/2. It is in quadrant 4, so the y value is negative. So we will get arc sine of negative 1/2. And then what is arc sine of negative 1/2? What is the angle that gives us that ratio? Well, it's pi over 6. But pi over 6 is the positive, and we want the negative, so we have to go in the negative direction to get negative pi over 6. Not 11 pi over 6, though, because it doesn't fall within that range. So this is equal to negative pi over 6. So either way will work, but you do have to pay attention to what that angle is that we're looking for. And remember, only if they're inverses of each other. So you can't have an arc cosine and a sine. It's got to be arc sine and sine, arc cosine, cosine, things like that. Let's take a look at example 2 here. Example 2 says sine of arc cosine of 3/5. So I have them switched around. The arc cosine is the inside function. So what is the angle that gives us 3/5? Well, that's not one of our familiar angles or ratios is 3/5. So what we're going to do is we're going to create the triangle. It is positive and it is arc cosine, so it needs to be in quadrant 1 when it's positive. with theta being the acute angle. arc cosine is, or cosine is adjacent over hypotenuse. So we can then find the third side by using Pythagorean theorem. 3 squared plus y squared is equal to 5 squared, and this should be a familiar one to you guys anyways, but 25 minus 9 is 16, so y is equal to 4, and everything is positive because we're in quadrant 1. So what's arc cosine of 3/5? Well, we don't necessarily need to know that exact angle because arc cosine is the angle for that ratio. So we can say that sine and then arc cosine, this whole thing, is equal to the angle measure of theta. So then, well, what's sine of theta? Well, sine of theta, since we have our triangle drawn out, sine of theta would be opposite over hypotenuse, therefore is 4/5. So this whole thing is equal to the ratio 4/5. Once again, arc cosine of 3/5, you're not going to find the exact angle measure. You're going to set up the triangle so that you know where theta is and what the ratios indicate of the side lengths of the triangle, and then you can find the trig function based on that information. So here's another example, and if you want to pause the video and go ahead and try this on your own, it works out kind of the same way. You got arc cosine of negative 2/3. Once again, arc cosine. Remember, arc cosine has a range value between 0 and pi. So with it being negative 2/3, we are in quadrant 2. And you have your angle theta, and then arc cosine is adjacent over hypotenuse, so you're going to have a negative 2 there for your x, and then you're going to solve for your other side length, so that would be negative 2 squared plus y squared is equal to 3 squared, and so therefore y squared would be 9 minus 4 is 5, and so y would be equal to the square root of 5, and it will be positive because you are in quadrant 2, so the y value is positive. So arc cosine of negative 2/3, once again, this whole thing is equal to the angle measure of theta. We don't know what theta is, but that's okay. We can still answer the question, what is tangent of theta? Tangent of theta is opposite over adjacent, so that would be square root of 5 over negative 2, so we'll rewrite that as tangent of theta is equal to negative, and we'll just put it out front, square root of 5 over 2. So this whole thing is negative square root of 5 over 2. And that's what we're trying to answer. We're trying to answer this whole question here as to what is tangent arc cosine of negative 2/3. So we're answering this whole thing right here, and it's equal to the ratio negative square root of 5 over 2. Remember, when you're doing these, when you're doing arc cosine or arc sine or arc tangent or the inverse, you're looking for the angle measure. When you're doing sine, cosine, and tangent, you're doing it of an angle and looking for the ratio. So we're looking for tangent of what's inside of there. So therefore we're looking for the ratio for tangent of that angle. Alright, let's look at some calculator questions. Find the value of each expression in 2 decimal places. We're going to do inverse of cosine of 0.4. So think about this. You have the ratio, you're looking for the angle. First thing you need to do is make sure that your calculator is in radians, so you can see right there that I'm in radians, and then we're just going to plug in inverse cosine. Make sure you press second cosine, so it's inverse. You'll see the negative 1 there. Inverse cosine of 0.4, and you get 1.159. So since this is a 9, the 5 gets rounded up to a 6 if we're rounding to the nearest hundredth, so this would be 1.16. And I don't necessarily need to write this, but this is in radians. That's 1.16 radians. When you look at the next one, you got arc sine of negative 2. Now before I go and plug all this in, but you can kind of already see it, is remember, when you're plugging that domain in for sine, or arc sine, your domain is your range of your original, and that means that you can only plug in values from negative 1 to 1. So you see that we're plugging in negative 2, or at least trying to, and so when we do the inverse of sine of negative 2, we get this air domain, and that's exactly why, because negative 2 is not part of your domain. So since it's not part of our domain, this right here, in terms of arc sine of -2, does not exist. So it's not a value that you can find because it's not within our domain. Alright, on this next example, it says use an inverse trig function to write theta as a function of x. You guys have actually done this before. It would be an example where maybe I would give you two side lengths and ask you to find the angle measure. How would you set that up? Well, what side lengths do you have? 7 represents your adjacent, x represents your hypotenuse. So which trig function? That's cosine. So normally we'd say, okay, cosine of theta is equal to 7 over x. But we want to write a trig function to write theta as a function of x. Basically what we want to do is solve for theta. And so to solve for theta, we are going to use the inverse of cosine. And so theta would be equal to the inverse of cosine of 7 over x. And that's really all you need to do. Now we're not solving for anything. We don't even know what x is. But it's just working on being able to use your trig functions, know when to use the inverse, and know when to use the function itself. Alright, and then on the last example here, we got an application problem, so you can kind of read through it. See if you can write angle theta as a function of the height of x. So similar to what we just did a second ago, I'm going to give you the opportunity to kind of read through this and see if you can set this up on your own. So go ahead and pause your video at this time. Alright, so hopefully you took an opportunity to kind of read through this and try to see if you can write that function. So one thing in terms of where theta is located, theta is this angle down here with angle B. What trig function will we use? Well, we have the opposite side in terms of x, and we have the adjacent side in terms of the 300 meters. So that would be our tangent function. So you can either do this in one step or two steps. I'm going to do it in two on this one. So we'll say tangent of theta is equal to opposite over adjacent. But we want to write it, the angle theta, as a function of the height of x. So we're going to rewrite this as the inverse, and I'll write it as arctan, or inverse of tangent, of x over 300 is equal to theta. And so that represents angle theta as a function of the height of x. Now let's go ahead and take it a step further. Part B says find theta when the height is 150, 300, and 600 meters. Round to the nearest hundredth. So you're taking the height, which is x, and replacing it with these three values. So we will say the inverse of tangent, or arctangent, either way, is equal to, the first one I'll do is 150 over 300. And that's equal to, I'm just going to call it theta 1. If you plug this into your calculator, you will get an angle of 0.46. And once again, don't forget, this is in radians. You don't have to write it because it's in radians, but it is in radians, so make sure your calculator is in radians. So that's for 150 meters. We'll do the next one at 300, so inverse tangent of 300 divided by 300, which obviously can be simplified to 1. We'll call that theta 2. This will give you an angle measure of 0.79. And once again, I'm going to write radians just so we're clear. And then the third one will be 600 meters. So we have, once again, inverse of tangent of 600 divided by 300, which simplifies to 2 there. And that will be theta 3. So the third one here is equal to 1.11 radians. So you can see as the height of the balloon increases, the angle of elevation also increases. So that is inverse trig functions using compositions. Some of the stuff should look familiar because we have done it before in terms of our applications, but it's been more calculator stuff. But that wraps up inverse trig functions with compositions.